Hey all, today we should be starting our new unit called Systems of Equations. So if you are not here, that's the only reason you need to listen to this video. If you click on the 4A notes, you will see a link to them. You can either print them if you have a printer, or you can use the Kami extension. But if you are here today, you are getting the notes. So we're going to be on pages 1 and 2 today. Okay, so it looks like this: Intro to Systems of Equations. So Jules opened a checking account with $500 and plans to spend $50 each week. Astrid opened a checking account with $50 and plans to save $25 each week. An equation showing the relationship between X, the number of weeks, and Y, the account balance, is shown for each account below. Graph each equation to use the graph to answers A through C. Okay, so first we have Jules. Jules had $500 in her banking account, so she starts with 500. Okay, and she's spending $50 a week, so that's why we have a negative 50. So every week she is spending $50. So she spends $50 every single week. Okay, I'm not going to draw a line because I'm not good at drawing them on this. So then we have Astrid. Astrid starts with $50 in her banking account, and she saves 25 each week. So she has a positive 25x. So we're going to add 25 every week. Okay. So part A says, where do the graph lines intersect? So they intersect right here. So that is the ordered pair 6, 200. What does the point of intersection represent in the context of the situation? Well, 6 is representing the number of weeks, and 200 is representing the account. Okay, so this would mean they would both have $200 in their bank account after 6 weeks. Prove that the point of intersection is a solution to each of these equations by substituting the values into the equation. Okay, so here's Jules, and we're going to check to see if 6, 200 is a solution. So I'm going to plug in 6 into this equation. Okay, so negative 50 times 6 is negative 300, and negative 300 plus 500 is 200, which is our output for this equation. Okay, for the other one, for Astrid, she has $25 a week plus 50. And again, we're checking to see if 6 works. So 25 times 6 is 150. And 150 plus 200 is also 200. So that is a solution for both of them. Okay. So a system of equations is 2 or more linear equations that use the same variable forms, same variables to form a system of equations. Okay, so in this case, our variables were weeks and money, and we could write a system because both of these people were talking about weeks and money. The solution to a system of equations is the intersection point that makes all of these equations in the system true. Okay, so we are looking for an intersection point or an ordered pair x comma y. Okay, when a system of linear inequalities equations is graphed, we can find the solution to the system by looking at the point of intersection. In these examples below, graph the system of equations, find the solution to the system, and check your solution by substituting in the equation. Okay, so the first one we have y equals negative 1x minus 2 and y equals 1/2 x plus 7. So the first thing I'm going to do is I'm just going to graph this first one. So start at negative 2, and the slope is negative 1, so I'm going to go down 1, right 1. Okay, and then I'm going to go backwards because we don't really know where this is going to cross or if it's going to cross. Again, I'm not going to draw a line, but you can. And the second equation is y equals 1/2 x plus 7. So here's 7, starting at 7, and we're going to go up 1 over 2. Okay, so then I'm going to go backwards. We're going to go down left. Okay, so it looks like our solution is right here because that is where it crosses, and that would be -6, 4. Okay, so to check this, okay, I'm going to rewrite my equations. Okay, but now instead of x and y, I'm going to check this ordered pair. So -6, I'm checking to see is the x, and 4 being my y. Okay, so -6 is the same thing as a 6, and 6 minus 2 is 4. So that makes that true. Okay, if this is a system, it should work for both of them. So we're also going to check 1/2 x plus 7. Okay, so again, I'm checking -6 for my x and 4 as my y. Okay, half of -6 is -3, and -3 plus 7 is 4. So that works for both of these equations. So we know for sure that -6, 4 is a solution to the equation. Okay, the second one, y equals -5, and y equals -2x minus 3. So this first equation, y equals -5, okay, this is one of those weird equations. This is a Hoyle equation. Okay, so it means it's going to be horizontal, which means it's going to have a 0 slope, and it is at -5. Okay. For the second equation, y equals -2x minus 3. So I'm going to start at -3, and I'm going to use my slope of -2 to 1. Okay, so I can already kind of see where it crosses. And it looks like it crosses at 1, -5. Okay. To check to see if this is right, we can check our equations. Y equals -5. Well, y equals -5. There's no x to put in, so that one works. The second one is y equals -2x minus 3. So I'm going to check by putting in x as 1 and seeing if we get out -5. -2 times 1 is -2. -2 minus 3 is -5. So this works for both equations, so we know our solution. Okay, so what I want you guys to do is I want you guys to try 3 and 4. Go ahead and pause this video and see if you guys can get the answers. And then after you are done, hit on pause and see if you get it right. All right, for number 3, we have y equals 5x plus 5 and y equals -3x minus 3. So first we're going to start at 5, and we're going to go up 5. Oh, we can't really do that, so we're going to go down instead. So we'll go down 5, left 1. Because if we go left 1, that still shows that positive, and this is a positive 5. Okay, so then we'll do that again. Okay, so we really just have 3 dots right now. Okay, then the other equation, we have y equals -3x minus 3. So we're going to start at -3. We're going to go down 3, right 1, down 3. I'm just going to kind of use my imagination. And then I'm going to go backwards. I'm going to go up left, so I can already see where it crosses. Okay. So it looks like it crosses at -1, 0. Okay, I could check and see if I get this right. 5 times -1 plus 5, that's -5 plus 5, and that's 0, which is my output for this one. And for the other one, -3 times -1 minus 3. 3 minus 3 is 0, so it works for both of these equations. Okay, for the fourth one, x equals 5. This is one of those weird equations. It doesn't have a y, so this is a Vux equation, which means it's going to be a vertical line at 6. My other equation is y equals 2/3 x plus 3. So start at 3, go up to right 3, up to right 3. Okay, so it looks like it crosses at 6, 7. Okay, if I check my work, x equals 6, well, x equals 6, yep. Y equals 2/3 x, so 2/3 of 6 plus 3. 2/3 of 6 is 4, and 4 plus 3 is 7, which is my output for this one. So it looks like this is the solution. Okay. Pedro is 10 miles from Sam's house and is driving at a rate of 0.5 miles per minute, to meet Sam. Sam leaves his house driving at a rate of 0.75 miles per hour to meet Pedro. The system represents the situation below. Okay, so first, this what is Pedro. Okay, he is 10 miles away, so he wants to get closer to Pedro, so he's getting closer by going negative. Okay, and this is Sam. Sam starts at home, and he is going closer to Pedro, so he has a positive. Okay. First thing it says to graph the system. So first we'll graph Pedro. Pedro starts at negative 10. Okay. So the issue right now is the slope is negative 0.5. Okay. So we can convert this into a fraction. I would prefer that personally. If you type in negative 0.5 and hit math fraction, it'll convert it to negative 1/2. Or if you know that it's negative 1/2, that's awesome. Okay. So we're going to go down 1 over 2. Okay, we can also just know that like I'm getting closer by 1/2 mile every 1 hour. Okay, which if you go another hour, that would be at 9 miles. So I'm going to keep following the same pattern. You can draw the ones in between, but you don't have to. Okay, for the next one, y equals 0.75x. Again, you can type 0.75 in your calculator, hit enter, and then hit math frac enter, and it'll convert it into a fraction for you. Or if you already know that it's 3/4 x, that's fine too. Okay, so he's starting at his house, and he is going 3/4 of a mile. So it's going to take him to go 3 miles. It's going to take him 4 hours. Okay. So it looks like it crosses at 8,6. And what does this mean in this context? It will take 8 minutes for Pedro and Sam to meet or be at the same distance. Okay. Number 6, list the system of equations represented on the graph as well as the solution. Okay, so we can see that they intersect right here. So the solution is 8,50. Okay, and it's asking just to write the system. So basically we just need to write these two equations. So I'm going to write this one first. Y equals, slope-intercept is my favorite. Okay, it starts at 10 and has a slope of 10 to 2. Okay, so 10 to 2 is equivalent to 5x, and it started at 10. Okay. All right, for the second one, y equals, starts at 90, and it goes down 10 over 2. So negative 10 to 2 is a negative 5x. And again, it starts at 90. All right, number 7, create a system of equations with a solution of 4,2. Okay, so we want the solution to be 4,2. You could pick really anything. You could pick a line that has a slope of 1. So that would be y equals a slope of 1x. And when I go to the starting point, it starts at negative 2. You could also have it have a slope of negative 3/4. Okay, this has a slope of negative 3/4. And it would start at 5. Okay, this is just an example. There is many examples that would work for this problem. Okay, so for today, your practice is on pages 3 and 4. You are just graphing and solving them, and then I will see you next time we have class.